Okay, let's now calculate the numerator, the probability that the sum is greater than 7 intersected with the probability of the first greater than 3. And so again, we're going to need to give this a name. Let's call this just let's just call this event B so that we don't have to write so much. So this is what we want to calculate. So event B is just this event where the sum is greater than 7 and the first one is greater than 3. And let's try to use the same partition above. So the probability that B occurs is going to be the probability that B occurs given that the first one is 4, 5, or 6, okay? Given E first 4, probability of E, 4 first, let me do it that way. 4 first, plus the probability that B occurs given that E of 5 is first times the probability that E of 5 is first, plus the probability of B given that E6 is first times the probability that E6 is first, plus the probability that B occurs given that E1, 2, 3 is first times the probability that E that 1, 2, 3 is first. Okay, so let's see if then how easy this is to figure out. This is the numerator of the problem at the end. Problem we were trying to solve of what's the probability the sum is greater than 7 given that the first was greater than 3. Okay, well this one is the probability that the we want to know what the probability is that the first one was greater than 3 intersected with the sum greater than 7 given that the first one was a 4. So if I look at the definition of this conditional probability, that's going to be the number that E4 first, and this is satisfied. So it's given that the sum is greater than 7, given that 4 are first. So this is going to be the number of elements in this set 4, 4, 4, 5, 4, 6, because this is the case when the first one's greater than 4 intersected with the 4 being the first one, but where the sum is also greater than 7. That's 4, 4, 4, 5, 4, 6 times the probability of E4 first. And we calculated these probabilities. This first one, we know that these are all 1/6. So we know that this one is 1/6, this one is 1/6, this one is 1/6, and we didn't calculate this one yet. Okay, so we can put this in maybe here to be 1/6 plus, well, we have the conditional probability that the 5 is first over E5F of the number of outcomes where the 5 is first, and in the numerator is going to be the number where these both occur. So if that's going to be the number of elements where you have a 5, and the second one makes it greater than 7. Well, it's going to be 5, 3, 5, 4. This is because this is 8, 9, 5, 5, 5. Oh, sorry about that. I was not making, oh yeah, 4, 5, and 6, because we have 5 here, so we have more items because we have 5, 3 is 8, 9, 10, and 11 times 1/6 for the 5 here, plus the number, here's where the 6 is first. We have 6, 2, 6, 7, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6 over the number with 6 first times 1/6 plus this number here where it's a 1, 2, or 3 first, given that the first, given this of the intersection of things where 1, 2, 3 are first, and the first one is greater than the first one is in B. Where did we put B? B is this one here where the first one is greater than 3. So this one's still 0 because the first one can't, if you know that the first one is 1, 2, 3, then it can't be that it's also greater. The first one can't also be greater than 3. So we don't actually need this to calculate. And that's the whole part of the point. We don't have to calculate this one probability. Now, this is going to equal, well, the number where 4 is first, this is going to be like 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, or 6. Each of these is going to be 6 because the first one is given, but the second one can be anything. So this is going to be 3 over 6 times 1/6. This is going to be 1, 2, 3, 4 over 6 times 1/6 plus 1, 2, 3, 4, 5, 5 over 6 times 1/6. So that's going to equal this is sort of like 36 for 3 denominators. So we're going to have 3 plus 4 plus 5, 3 plus 4 plus 5 over 6 times 6 is 36. So this is going to be 4 plus 5 is 9 plus 3 is 12 over 36. And we can factor out a 2 to get 6 over 18. Oh, well, or just to see, maybe do this in a simpler way, 3 times 12 is 36. So this is going to be 1/3 because I can divide out both numerator and denominator by a 1/12 because or factor out the 12 equals 12 over 3 times 12. Okay, so that after this laborious procedure, the numerator is 1/3 here, and the denominator was 1/2. So we're calculating the conditional probability for 2, the probability that the sum was greater than 7, given that the first greater than 3 is going to equal 1/3 divided by 1/2, because that the numerator is this 1/3 here, the probability of the intersection, and the denominator is the probability that's greater than third, which is 1/2. So that's going to be 1/3 times 2 over 1, which equals 2/3. So this has been a lot of work, but otherwise it's hard. It's maybe hard to see what this conditional probability is to come up with the 2/3 here. So this is this is a complicated example to work out using these conditional probabilities. And I've written out solutions to all these, and I'll put them up on GitHub so you can sort of work on these and see, or at least follow the solutions. That's not what I meant to do. I meant to